All right, so here's our first one we're going to do today. This is just like where we finished off yesterday. So we are asked to find the value of sine of 23 pi over 12. So we need to figure out some set of angles that we can add or subtract to get to 23 pi over 12. That's, you're thinking coterminals of the complementary. We're just evaluating, so we're going to be using our sum or difference formulas. So we want some pair of numbers that's going to add up to make 23 pi over 12. What did I say? 11 pi over 6 plus 1 pi over 6. That would just give us 12 pi over 6. We want over 12. Yep. Yeah, it'd be 24 over 12. So it'd get us close, but not quite where we want it to be. So think about our unit circle angles and they're getting them up to be 12ths. You don't have to necessarily do the whole circle, but we're going to think through most of them, or think through a good chunk of them at least. Like we normally think about our pi over 6, but that would be 2 pi over 12. We could have our pi over 4, which would be 3 pi over 12, or our pi over 3, which would be 4 pi over 12. We could have our pi over 2, which would be our 6 pi over 12. So 12. Keep thinking through things and see what we can come up with that we're going to have either a sum or a difference of 23. So if we had pi, that would be 12 pi over 12. Okay. Yeah, I was like, if we had over 12s, that would work. So I'm going to give us a couple that I think will be helpful for us. If we have our, look down here. So let's look at our 5 pi over 3. If I put that one in 12, so it would be 20 pi over 12.
So pi over 3 plus pi of sine.
Yeah. So my 5 pi over 3 and my pi over 4, that's going to give me 20 pi over 12 and 3 pi over 12. Those will add up to be 23. So we have to sometimes think through bigger portions of our circle. I can write this as sine of, I'm going to do it unsimplified fractions first, our 20 pi over 12 plus our 3 pi over 12. That's the same thing as if we have sine of 5 pi over 3 plus pi over 4, right? So finding those two pieces is the tricky part. From here, we're plugging and chugging through that formula that we had. I had it up on the board and we wrote it down yesterday, where we have our sum of angles in sine, where sine takes sine of the first one, so sine of 5 pi over 3, and then our cosine of pi over 4. And then we're going to add our sine of pi over 4 cosine of 5 pi over 3.
Question.
Yes, dear.
Would we have to simplify the like what you did with 20 pi over 12? Do we have to simplify that to like
You don't necessarily need to write this step, but we would want to have them in our unit circle angles. So we want to have it here, but just this step sometimes makes it easier to see what we did. So you don't necessarily have to write this step as long as we have angles that will get us there. But you do want to have them in your unit circle angles because I know sine of 5 pi over 3. I don't necessarily off the top of my head know the sine of 20 pi over 12. What's up, David?
What's that? Is that 5
This one?
No, what you wrote.
This one here? Yes, that is a 5. And we'll make it a better 5. There we go. So then we're going to get our exact values. What is the sine of 5 pi over 3? Negative root 3 over 2. What is our cosine of pi over 4? Root 2 over 2. That was the weirdest root I've ever drawn in my life, but that's okay. What is the sine of pi over 4? Root 2 over 2. And what is the cosine of 5 pi over 3? 1/2. So we're going to do these multiplications and we're going to simplify it out. Our negative root 3 over 2 times root 2 over 2 is going to give us what?
Negative root 6 over 4.
Negative root 6 over 4. And we're adding that to, what do we get on the right-hand piece? Root 2 over 4. So we can combine these into one fraction, but that's about as good as it gets. We're going to be over 4, and we've got our negative root 6 plus 2, or plus root 2, excuse me. Or, if it bothers you to have that negative out in front, we can do root 2 minus root 6. I genuinely do not care which order you put them in. Both are fine. Okay. So we've done them with sines, we've done them with cosines. We're gonna try the ucky tangent ones. We haven't done those yet. Tangent ones are gross. But we're gonna look at a tangent. So we're gonna look at tangent for pi over 12. We've dealt with the over 12s a bunch. So same thing. Pi over 12 is not an angle we know. So we need to find a pair of angles that will add or subtract to give us that value.
Pi over 2.
Mm-hmm.
Pi over 3.
If I do pi over 2 plus pi over 3, that's going to give me 5 pi over 6.
Oh, that's yeah. Pi over 4.
Mm-hmm. Yeah, if we do pi over 3 minus pi over 4, because if I put those in common, so let me do it. Pi over 3 minus pi over 4, that's the same thing as if I have 4 pi over 12 minus 3 pi over 12. So that's when it really helps sometimes to put them into that common denominator, just like we did up here. My 4 pi over 12, if I subtract 3 pi over 12, it's going to leave me with my 1 pi over 12. So putting them into that common denominator really helps because these are our two guys we're going to look at. When we fill in that formula for tangent, it's unpleasant. We're going to have our tangent of pi over 3 minus the tangent of pi over 4. And our denominator is our 1 plus tangent pi over 3 times tangent of pi over 4. So it uses a product in the denominator. So it's going to be really, really helpful if we know what the tangent of each of those are. So tangent of pi over 3, if you need to, split it back into our sine pi over 3, cosine pi over 3.
Square root of 3.
So tangent of pi over 3 is going to be our square root of 3. What is tangent of pi over 4? 1. Because that's when we'd have our square root of 2 over 2 over square root of 2 over 2. So our tangent is 1. Okay, so when in doubt, find those pieces, because now we know that our tangent of pi over 3 is square root of 3, and our tangent of pi over 4 is 1. So I can rewrite this as my root 3 minus 1 over our 1 plus square root of 3 times 1, which is just root 3. But do we get to keep radicals in the denominator? No. But how do I get rid of a radical like this? Do you remember?
1 minus.
We have to multiply by the conjugate. Because we have to make a difference of squares to get rid of that root. If I just multiply by square root of 3, I get square root of 3 times, or square root of 3 plus 3. So we have to multiply this by our 1 minus root 3. 1 minus root 3. Because we have to use that conjugate. Because that will make the bottom one be a difference of squares. My denominator will become our 1. We get plus root 3 minus root 3 minus root 3 squared, if I multiply that out. For my numerator, we'll get root 3 minus, let's see, root 3 squared. Minus 1 times 1 gives me minus 1. Minus 1 times minus root 3 gives us a plus root 3. So multiply things out as needed. We've got a couple of pieces in here that are canceling out. These guys cancel. The numerator is going to be a bit of a mess. We've got our 1 minus square root of 3 squared. So we've got 1 minus 9. We've got square root of 3 squared. So we've got 2 square root of 3's minus 9 minus 1. 3 squared. Oh, you're right, 3. Should be 3's. I'm crazy. Call me out, y'all. I mean, definitely, totally making sure we're paying attention. Yes, those were not 9s. Those were 3's. Totally just making sure we're paying attention, 100%. Any teacher who says they don't make mistakes is a big old liar. Okay, so just our last bit, simplifying these things out. We've got a negative 2 in our denominator. We've got our 2 root 3 minus 4. And we're almost there because we can simplify this because everybody here divides by negative 2. So we're going to have our negative root 3 plus 2. Yes, dear? And the numerator, because they were in fact both positive. This guy's positive. This one is square root of 3 squared. So this is our minus, that's our minus 3.
Wait, can you also write it as root 3 minus 2? Or no?
Wouldn't be root 3 minus 2, but you could do 2 minus root 3.
Okay.
Okay. So the tangent ones are gross. We don't ask you tons of those, but they're there. They're a thing. We can do that. Another way they're going to give us problems is sometimes they're going to give us the formulas all the way filled in and have us write it the original way. So sometimes, especially in the homework, they give us problems like this. I promise these ones are actually easier. So we're going to see what this is. They're giving us cosine of 78 degrees times cosine of 18 degrees plus sine of 78 degrees times sine of 18 degrees. So what we're going to do is we're going to compare these with these guys and see which one it matches with. So I see cosine times cosine. So looking at these guys, we're looking at cosines. And since, yep, y'all are right on top of it. Because there's a plus in there, we're looking at this guy. So if I rewrite this into our single trig function like this one, we're going to have this be cosine of our 78 degrees minus the 18 degrees. What is 78 degrees minus 18 degrees? So cosine of 60 degrees. What's cosine of 60 degrees? 1/2. Told you these ones look complicated, but they're not awful. Okay. And then also remember, when it says in these instructions, it says, if possible. Just pointing that part out. Here's our next one. It's a very similar vibe. So you've got sine of 140 degrees times cosine of 50 degrees. So we've got sines and cosines mixed together. So that means we're going to be looking for which trig function? Sine. And it's, yes. Sine maintains the signs. Cosine likes to switch things on us. So we're going to take our 140 degrees plus our 50 degrees. So this is going to be sine of what angle? 190. Is that an angle we know?
No, but like.
So it goes up by 15, it would be the next one.
Yeah, it's 10 degrees further than our x-axis, because that would be 180. If we thought of our unit circle, this guy's 180. So we'd be at 10 degrees more here. That's not somebody we know. Okay, so this would be one of those if possibles. We could look through and see if we could come up with something that would add up to that. I was going to say it's just going to be in like slightly more awkward pieces, but I still don't think we have any sums or differences that'll get us there. So when they say if possible, don't hurt yourselves. Not possible. We don't have things that'll do it. Okay. So sometimes they give it to us in degrees. Sometimes they give it to us in radians. Same vibe. Yes, dear. We have to just kind of match it up with our functions over here. I'll put it back in a second. So like on that one, just going back to it for a second, since we had sine and cosine mixed together, that means when looking at here, we're looking up at these guys. And since our equation had a plus in the middle, if we look at our signs, the one that has a plus, we added these two. So we're just kind of matching the formulas to this side of this formula and putting it back over here. So let's do our next one as soon as my iPad unfreezes. I swear this thing must be from like 2003. Whoa, it's frozen hard. Wake up. Ooh, there we go. I could at least get. There we go. We're back. As I say, I was just about to end the program. All right, so sometimes we're going to give it to you in degrees, sometimes we're going to give it to you in radians. So here we are in radians. We've got cosine of pi over 7, cosine pi over 5, minus sine of pi over 7, sine of pi over 5. Yep, so we know since our cosines are together, we're looking at our cosine. And we just have to figure out our relationship between our pi over 7 and our pi over 5. Those are our two angles. Yes, and so we look at our equations carefully, and we notice that cosine uses the opposite sign over here. So if we add our two angles together, we would subtract these two pieces. If this was a plus, this guy would be a minus. So then we want to figure out what that is. What is pi over 7 plus pi over 5? Yeah, we get these to our common denominators. So 5 pi over 35, multiplying by 5 over 5. Multiply by 7 over 7 on this one, pi over 35. When in doubt, multiply by the denominator of the other fraction. So 7 times our 7, pi over 5. So what we're asking for here is cosine of 12 pi over 35. Is that an angle we know? No. Our pi over 7 or pi over 5 angles we know? No. So that's another one of those where they say, if possible, it's going to be very limited when it is possible. Okay. So I'll just pull a couple of these because we see those in the homework and we go, huh, and they're really not that bad. It's matching with the equations. Okay. There are a couple more types of problems that they like to give us. So this one, it has an instruction that's going to make you a little bit. Oh no, we got one more like this. Sorry. One more like this. What's up? Back on this one? Okay. One more like this, and then we're going to go through a couple more kind of weirdy ways they'll word stuff. So we're putting this as a single trig function and evaluate if we can. We've got cosine of 3, sine of negative 2, minus cosine of 2, sine of 3. We've got to be really, really careful, though, because are these the exact same angle?
No.
I was saying negative 2 is not the exact same as 2.
Wait, is it only like secant and something else where it's like the same thing?
I was going to say, that's what we're trying to think of right there. Is it even or is it odd? Does it keep the negatives or does it lose the negative?
It keeps the negative. No. Yeah.
So cosine of 2 is the exact same as if we had negative cosine of 2 of negative 2, right? No, sorry. It's the same thing because it loses the even because it's reflective over that y-axis. So cosine of negative 2 is the exact same thing as cosine of 2. They just simplified stuff to make things weird.
Wait, is the other one secant?
Yes, because cosine and secant react the same way. So if they had something like this and they did it with our sines, just theoretically doing it down here. If we had sine of negative 2 would be the same thing as negative sine of 2. So sometimes they will play games with signs like this. They didn't with our sine, but they did with our cosine. So just being careful with this. This does mean the exact same thing as cosine of negative 2. We just got to be careful because they're being annoying. So this is the same thing as if we had our sine of negative 2, cosine of 3, minus sine of 3, cosine of negative 2. It means the exact same thing. These are now like way too darn close to each other. I'm just going to scooch this over just a smidge, just so they're not lined up. So it is still our function. It's just weird, and they're playing games with signs. So which trig function is this the formula for? This sine, cosine, sine, cosine. Are we looking at sines or are we looking at cosines?
Sine, subtraction.
Sines, yep. Now we're looking at our equations over here. There they are. So sine, cosine, and we had a subtraction sign. So we're going to do what with those two values? Subtract them. So we're going to have our -2 minus 3. So what is this really asking us for? Sine of? -5. So this is pulling in some things from last chapter. Oh, I'm gonna put sleep. Thank you. She's not here today. What's up? Yeah, I'm ready to test. Okay. So sometimes they play weird games with signs and it'll pull back the evenness versus oddness kind of stuff. So you just gotta be careful. The next kind of problem they're gonna throw at us is gonna be something that looks like this, where we talk about verifying. We always get a little scared when we see the verify at the top because we're like, oh no, verifying. We're going to be using the things we've been talking about. So I'm going to talk us through it. All right, so here's our next one. We got sine of x plus pi over 3, and we want to know if that equals opposite of sine of x. So I'm going to take this left-hand side, because I've got an angle sum right here. And I'm going to put this through the angle sum for sine. So I can write sine of x plus 3 pi as our sine of x cosine of 3 pi plus sine of 3 pi cosine x, right? That's the sine sum formula. We put it through that guy. Getting rid of the greens. We'll put it through this guy, right? Ooh. So, ooh, that's not the highlighter.
Oh, so they give you like the
A,
okay,
B. So angle A, angle A, angle B, angle B. Through that guy. That one, okay? Everyone see where we are now?
You can't distribute signs.
No, it has to go through the angle sum formula. They don't distribute the way we expect like a number to. But there's pieces in here we do know. What is the cosine of 3 pi? Ooh, I've heard many a choice. I was going to say, because it's coterminal with pi. So cosine of pi is -1, right? So we have sine of x times -1 right here. Plus, what is sine of 3 pi? 0 times cosine of x, right? We're not asked to solve. We're just verifying. So we're just working with the one side. We want to see if we can get it to equal that.
Oh.
Okay? So we have sine of x times -1 minus sine of x. We like that. And then 0 times cosine. It's just 0. Anything times 0 is 0. So we get minus sine of x equals minus sine of x. Boop. Okay. So they're less awful than they look. We see verify and we panic. Let's practice another one. I'm gonna show you that sometimes tangents don't suck. So here we have tangent of theta plus 3 pi. Okay. So we're gonna use our tangent formula. And yes, the tangent formulas suck. That's the official diagnosis. So we're gonna fill it in. We're gonna have our tangent of theta plus our tangent of 3 pi. And we're over our 1 plus tangent of theta times tangent of 3 pi. So start by filling things in.
Oh, tangent of 3 pi is 0.
Tangent of 3 pi is 0. Does that make things a little bit easier to deal with?
Yes.
Because tangent of 3 pi, remember it's coterminal with pi, so tangent of 3 pi is 0. So that means this thing is really saying tangent of theta plus 0 over 1 plus tangent of theta. Let's see, let me put the plus 0. Oh, you're right, it should be minus. 1 minus our tangent of theta, I was writing it down, times 0. Fixing that one too. Boop, there we go. What happens to my tangent of theta that's in my denominator here?
0.
Times 0. We don't even have to worry about it. Anything times 0 is 0. So we have tangent of theta plus 0 over 1, which is the same thing as tangent of theta that equals tangent of theta. So the tangent stuff doesn't have to be brutally awful. Okay? It's unpleasant. I agree. But it doesn't have to be the worst thing ever. Okay? I know. You do not have to like tangents. I also do not like tangents in this particular form. It's super gross. I like tangents in general. I don't like tangents like this. They're unpleasant. Okay, so there's one other way that they like to word questions in here, and we're gonna finish with these. We'll also start with these tomorrow, just because I want to practice them a few times because they're weird. So they'll give us things like this. They tell us that sine of alpha equals negative 5 over 13, and that our tangent of angle alpha is greater than 0, meaning it's positive. And we are asked to find sine of alpha minus pi over 3. So we got to tuck this to the side for now. Because when we're looking at our angle sum formulas, we do need to have both cosine and sine. So we need to figure out the cosine for alpha. In order for us to find the cosine of alpha, what we need to do is we need to figure out where the heck alpha is. What quadrant is alpha in if we know that my sine is negative, but my tangent is positive? If sine is negative, careful, because that means I also need my cosine negative. So in quadrant 3. So if I was to sketch this out, my little triangle, I know it's going to be down here somewhere. This is my angle alpha. I'm going to draw that bigger. So I'm erasing it just so I can draw it bigger. It wasn't because I did it bad. So if we think about this being on a coordinate plane, we're going to have some piece down here. This guy's the alpha that we've been talking about. What do we know about this thing? Yeah, we know our sine. We know our opposite over hypotenuse. Right? So I know opposite, that's going to be this guy. That's my 5. And my hypotenuse is 13. Which one of those things is going to grab our negative? Because we have a negative on our sign here. The 5. So how can I figure out my adjacent side? Pythagorean theorem. We get some side here. I'm going to call it B. And we know that our negative 5 squared plus our B squared is going to equal our 13 squared, right? So figure out what B is going to be. B is going to be 12. So this, once again, put my B back. Is it going to be a positive 12 or a negative 12? Because we're in quadrant 3, I know that my x's are negative and my y's are negative. So my both legs have negative values. Because we're in that quadrant, think of it as an ordered pair. So that means my cosine of alpha, what's cosine going to be? Negative 12 over 13. We did all of this so we could figure out what cosine of alpha was. Because when we do our sine formula over here, I need to have both cosine and sine. So this is stuff we did in the last chapter. We're just smashing it together with stuff from this chapter. Okay, so we've done things like this before. They're just unpleasant and not super comfortable. So when we're working with our, there we go, finding the sine of alpha minus pi over 3, then we're going to need our sine difference formula. So we're going to do sine of alpha cosine of pi over 3 minus our sine of pi over 3 cosine alpha. Sine of pi over 3 we know. We were given that one. That's our minus 5 over 13. What is cosine of pi over 3? Bless you. What is cosine of pi over 3? 1/2. Minus, what is sine of pi over 3? Root 3 over 2. And what is cosine of alpha? Negative 12 over 13. So let's simplify this one out. This will be where we finish for today. So we've got our negative 5 thirteenths times 1/2. Negative 5 26ths, which is super gross to say. Like, my tongue refuses to say 26ths without it sounding like I'm chewing on it. And then we have our minus root 3 over 2 times minus 12 over 13. I was going to say, we're going to have our 12 root 3 over our 26. What's going on with our sign so? This is negative. So we've got a double negative situation going on here. Yeah, so this is the same thing as having negative 5 plus 12 root 3 over 26. Or you can put it as 12 root 3 minus 5. That is also okay. Just watch out for these double negatives, okay? We will practice more with things like this tomorrow because we only barely touched it. This is where 7-3 ends. Since we just barely are touching the end of 7-3, I'm not having 7-3 due tomorrow. 7-3 will be due on Monday because we're going to finish out 7-3 and then we will start on 7-4 tomorrow as well. So we'll finish it. It is scheduled for the day before SATs. Okay, it's scheduled for the 5th. I was like, Miss Glaze, who's the other DC pre-cal teacher, is out today, so I will have discussion with her on Monday for sure on what we're gonna do with the quiz and what the plan is for that, if we want to change it or move or anything like that, because we always do everything together. But this is not due 2/28. We're gonna be doing 3-3? Zion, can you see the board? Did I put 7-3 as 3-3? Okay, cool. Just double checking, because I look at the calendar, but I don't have the calendar here.